In this question, we are trying to find a probability for a normal distribution, and I'll show you how to use x and also z to do the computation. A survey indicates that people keep their cell phone an average of 1.5 years before buying a new one. The standard deviation is 0.25 year. A cell phone user is selected at random, so just one. Question says find the probability that the user keep his or her current phone for less than 1 year before buying a new one. Assume that the lengths of time people keep their phone are normally distributed and it is represented by random variable x. So let us take a look at the area or the probability that we are dealing with. First of all, since you have a normal distribution and on the horizontal line you have x, which is the age of cell phone in years, the mean or the dividing number or the balancing point is 1.5 years, which is located exactly here or represented by this arrow here. Mu is 1.5 years. But what's the meaning of that? It means that it's located on the horizontal line. It says, hey, the area on the left-hand side of 1. Why on the left-hand side? Because it says less than 1. You have 1 just right here. Less than 1 is going to be any number on the left-hand side of 1. So below the curve, you're going to shade this little area. Now what? The z-score corresponds to 1 year can be calculated this way. Z, as you remember, is x minus mean divided by sigma. But what is x? X is 1 year, mean is 1.5 years, and standard deviation is 0.25. So x, which is 1, minus mean, which is 1.15, divided by sigma or variability, which is 0.25. When you do the calculation, it is equal to -2. So everybody, here you had x, 1 corresponds to x, and -2 corresponds to z. If I ask you to find a probability that x is less than 1, equivalently, you're finding the probability that z is less than -2. They are equivalent to each other. In a moment, I show you that you get exactly the same result. It doesn't matter if you use x or if you convert it into z and find the probability. Either case, you get 0.0228 or 2.28%. The probability is very small, 2.28%. So let's take a look at our calculator. In using our calculator, we're going to go to second, Mars, and find normal CDF. First, I'm going to show you how to use your x, then use your z. When you're dealing with x, question says, hey, x is less than 1. So less than 1, any number less than 1 is going to be 0, -1, -2, -3, -4. So for simplicity, we're going to use -100, for example. The upper bound is 1 year. What is mean? Mean is not 0. Standard deviation is not 1 because we are dealing with x. X is 1. And based off of the information from the example, mean is 1.5 years, and the standard deviation is 0.25 year. Now, if you go to paste, hit enter, enter again, you get the exact same probability, 0.02275. Since you have a 5 here, you're going to add 1 to 7, and you get 0.0228. So this is for your x. If you're deciding to use your z instead, first you have to do the computation and calculate z. We need to know what is z, otherwise we don't know what to enter. So click on second, vars, go to normal CDF, lower bound, you can keep it as -100, -10, -1000, anything works here. The upper bound, however, is -2 now. So -2. The mean must be changed to 0. For z, the standard normal distribution, mean is always 0 and standard deviation is always 1. Now go to paste, hit enter, and as you can see, hey, I got the exact same probability. So it doesn't matter if you use your x, which is 1, or you use z, which is -2. Just make sure you enter the information correctly. For your x, the lower bound, -100, x is 1, mean from the data is 1.5, standard deviation from the data is 0.25. But again, guys, if you decide to use z, you have to convert it. You have to take your x and see what is the representative on z-axis. Z is -2, and then mean is 0, standard deviation is 1. But again, it doesn't matter which one you use, you get the exact same probability. The probability that you randomly select a person and that person keep their phone for less than 1 year is 0.0228 or 2.28%. This is a very small probability. You can compare it with the average as well. The peak is around 1.5 years. So if it says, hey, what is the probability that people keep their phone less than 1.5 years? It's going to be this area, which is 50%. You don't even need to do any calculation since this line divides up the area into two equal pieces and it's 100% down the normal curve. On the left, you have 50%. On the right, you have 50%. So what's the probability that they keep their phone less than 1.5 years? It is 50%. But less than 1 year, as you can see, it is very small. It's 2.28%.